Morning. In the last classes we have learned about the general properties of a nucleus. That we have learned there are around 7 properties for the nucleus, 7 general properties for the nucleus. And today we can deal with the binding energy of nucleus. What is the the term binding energy consists, or what the binding energy actually represents. Binding energy. So you can see that if Z protons and n number of neutrons combine together to form the nucleus, there is a mass defect. That is, we will get a mass delta M, which is equal to the Z into a number of Z into mass of protons plus N into mass of 1 neutrons, mass of 1 neutron minus the real mass. That the real mass is always less than the sum. So this term is given by the mass defect. And according to Einstein, each mass, there is a mass energy relation, that is corresponding to the certain mass we will have some energy, and that energy is given by E is equal to mc square. Here m is delta m, so here E is equal to delta m into c square. So this mass defect, so this value of mass is, that is not there in the case of actual nucleus. If you are measuring the actual nuclear mass, the mass is somewhat less than the value of this total mass of the nucleons plus neutrons plus protons. So this mass defect actually given in the, or it is actually having the form of an energy, and this energy is known as the binding energy. This is actually known as the binding energy here in the case of nucleus. Binding energy of nucleus. That means the nucleus will be stable unless otherwise we are giving at least this much energy. Or otherwise, if the protons and neutrons are combined together, it will release some energy. So in order to split the nucleons, we have to supply that much energy. So after forming the nucleus, it is having a less mass. That means that mass is released in the form of energy. So that energy is the delta mc square, that is actually the binding energy. So in order to split the nucleus into protons and neutrons, we have to supply this much amount of energy. So if the binding energy of the nucleus is small, that means we have to supply that much amount of energy to split the nucleus into protons and neutrons. That means if the binding energy is more, the more stable the nucleus is. And it actually measures the stability against disintegration. So a nucleus if the nucleus is having a possible energy of binding energy, it is said to be in the ground state. So that is the E minimum. If the energy of the nucleus is greater than E minimum, that means there is some more energy for the nucleus here. So that then we can say that this this nucleus is in the excited state. That means it absorbs some more energy and it goes to the excited state. If the binding energy is greater than 0, that means that this one, if the binding energy is greater than 0, the nucleus is stable. That means the energy we have to supply to the nucleus. If the binding energy is less than 0, this is the stable one. And if the binding energy is less than 0, that means during the disintegration the energy can be released. So there is no need to supply the energy to the nucleus to disintegrate. That means the nucleus itself can disintegrate. That means the nucleus So here the nucleus itself can be disintegrated. There is no need of supply energy. Here we need to supply the energy to disintegrate the nucleus. Here there is no need to give extra energy to disintegrate. So this itself can be disintegrated. So this type of nucleus is known as unstable one. This type of nucleus is known as stable one. We can just give an example. We can take an example of a deuteron. So here we have one proton and one neutron. This is the isotope of hydrogen, that is the deuterium or deuteron. So it is having one proton and one neutron. So you can see what is the mass of proton and mass of neutron. The mass of proton is, it is in the atomic mass unit, AU scale, 1.02, 1.007276 atomic unit. Mass of neutron is 1.00865 atomic mass unit. The mass of proton plus mass of neutron is given by, you can add these two, that means 1, 4, 2. This is the sum of the two terms, but the actual mass of deuterium or deuteron is given by 2.0213553 much atomic mass unit. So you can see that there is a difference. Here it is 0.15, here it is 0.13. This is the expected mass, but this is the actual mass. So delta M is given by, you can subtract these two, that you will get 8. So there is a mass defect of 0.002388 unit. So you can see that when this proton and neutron combines to form a deuterium or deuteron, this much amount, the energy corresponding to this mass is liberated, so that the mass of the deuteron nucleus is only somewhat less than the sum. So the energy released or the binding energy here you can calculate. You can see that one atomic mass unit corresponds to 931 much mega electron volt. That means one atomic mass unit corresponds to this much energy. So the binding energy here is mc square, or the energy corresponds to that mass is that one. So energy corresponds to this mass is 0.002388 into 931 mega electron volt. This is equal to 2.23 mega electron volt. This same thing you will get when you will multiply, you will convert this mass into kilogram, and you can use c square, the velocity of light. The same value you will get. Otherwise you can directly go for this way, or you can, if you convert this mega electron volt, you can see that 1 electron volt corresponds to 1.6 into 10 raised to minus 19 joule. So if you multiply this with this value, you will get the binding energy in joule. That will be same as the binding energy, which is equal to delta M into c square. Here you have to convert this atomic mass unit into the kilogram value, then c square. Then you will get the same value when this value is multiplied by this value. That value will be same as this amount. So this mass defect, this difference between this mass, that is the mass defect, will be converted in the form of binding energy. So we have to supply that much energy in order to disintegrate, in order to remove, or in order to disintegrate or destruct this nucleus into its constituents, that is protons and neutrons. So in order to split the deuteron, we have to supply 2.23 mega electron volt of energy, it into one proton and one neutron.